All right, so this is a car battery and the resurrected NOCO for 24 volts, and this is on a Ready Welder 10,000. So yeah, start experimenting whenever you're ready, dude. No problem.
All right, that was at mid speed.
Probably want a little more stick out. Like we're flux. There's no issue with a little more stick out.
That was bad. That was at full speed.
All right, we just brushed these off. Geeking out on this a little bit. You know, this is our first time running Flux-Core wire, first time using the Ready Welder. But what were you just pointing out?
I think this weld right here, this was half the dial on speed, is the most structurally sound. This one right here,
Too much.
it looks like it got a little too hot right there, and then we're losing the weld. And this was at a lower speed, and then I sped it up here to about 3/4 of the way, and then this is max speed right here, which is just dumping. You could make this work if you went fast enough, because right here you can see that's a good penetrating weld.
Yeah. Well, it depends on what you're going for too, because you can see that last one, you were just piling the metal up higher, so you weren't really melting the base metal anymore.
Yeah.
So if you're gonna do that, you should probably have, I don't know, maybe 36 volts and thicker wire or something to be pushing that much.
Yeah, and then this one over here,
That was turned down quite a bit.
this was turned down almost to nothing right here. And that looks good, but there's still pitting right there.
Well, that's operator error, clearly.
Yeah, I'm sure it is, yeah.
All right, same deal. Car battery, NOCO. We're using the Ready Welder. This is Jimmy. And we're running 035 Flux-Core wire, if I didn't mention that before. So what we're trying now is thinner base metal. So this is like 1/8 inch-ish. And we got real slow wire feed speed that we're gonna try and just see if we can get a half decent bead on there without burning through.
All right, that's no good at slow speed.
Is that too slow?
Yeah, I'm going up 1 notch. That was pretty.
Did that lay down and not burn through?
Yep. Well, I don't know. What's it look like under there?
Oh, it didn't burn through.
Okay.
Heck yeah.
All right, I'm going up 1 notch on the speed.
Just trying to find the limit.
Yep. Yeah. You see how the weld laid down?
Yeah, because it's hotter.
Yeah.
So go back one setting to this one that was a little taller,
Okay.
and then I want to measure some of these currents while you're going.
All right. They went.
When? All right.
Dude, that was a beautiful weld. Look at that.
That was like 120 to 130-ish. Oh yeah, you got penetration.
Oh,
Actually,
yeah.
You burned through a little bit.
Yeah, sure did.
So that was even a little hot. But yeah, I like that adjustability.
Okay, so
on that lowest wire feed speed where you said you didn't like it, that was the pulse mode that they talk about. So somewhere in between there, you could get a lower power weld going.
So I'm in between the first one and this one right now. Let me see where this goes with this.
All right, I wouldn't weld more than a few seconds though, just because we need to cool this down. That was cooler. It was like 100 to 110 on the meter.
Let's see if I blew out the bottom.
No,
Nope.
you're good.
That's cool.
I like that adjustability.
I like that too, man.
Dude, 2 thumbs up to Ready Welder and NOCO. All right, so there was the last one, which was like 100 to 110 amps-ish.
Okay, so
There was the first one that was just spotting.
Lowest speed, second notch, third notch.
Yeah, these started to blow through over here.
This was like fourth notch, and then coming back to this one, this was in between 1 and 2.
Yeah. So the fact that you can, with the same wire, dial it down this much is pretty darn cool. And then of course, you could always you can always pull the trigger for a second and then let it cool.
Yeah,
Like stitch welding. Yeah, that's cool. So yeah, you could weld really thick to at least 1/8 inch. You could probably go thinner if you switch out the wire to a thinner wire. Pretty cool. All right, this is going to be a second test of the Ready Welder. And this time just with 2 lithium jump starter packs instead of a car battery and a jump starter pack. So the car battery and the jump starter pack worked great, but I'm just curious if 2 lightweight jump starters would allow you to do a bit of welding, because it's a lot more portable. So it's worth a quick test. So on the right we have the resurrected NOCO GB70, and on the left we have the Harbor Freight Viking compact lithium jump starter pack. And the Viking jump starter pack is pretty interesting because it has significantly more battery capacity than the NOCO, at least on paper. But the design is a bit different. It has its pluses and minuses compared to the NOCO design, but the wire gauge on the leads is a bit thinner. But there's plenty of spring pressure in the clamps. There's some good reviews on YouTube of it. And based on some of the current measurements I saw somebody else do, it should have enough current to do a bit of welding. But I'm just curious if it can do it without being damaged. So you see here we've got them wired in series. Something else I noticed was that the Viking pack, it doesn't like being connected and then put into jump starter mode while it's connected to the Ready Welder. It beeps and flashes the warning. So I'm guessing it's sensing something related to the little circuit board in the Ready Welder, and it's refusing to come on. So what I found is if I have it disconnected like I have here, and I put it in jump starter mode and then I connect it, then it seems to power up the Ready Welder just fine, and I don't get any warning beeps. But I haven't tried to weld with it yet. So run an 035 Flux-Core wire again. So the wire will be negative and the work clamp is positive. Okay, red light means we're electrode negative, which is what we want. So it has enough juice to weld. Might have hit the 1 minute timeout. Either that or I killed it. Yeah, that timeout on there is going to be a little annoying. Awesome. All right, so I am pretty stoked that that worked. So looking at the current measurements, so that was anywhere from 90 to 130 something amps it looked like on the current meter, even though that's not instantaneous. And that was about 5 inches of weld. And this is only my second time ever running Flux-Core wire. Not the prettiest, but I've seen a lot worse too. You see it over here, don't know what I'm doing. Started out a little cold. Then I'm getting tie in. So this works fine. Now, I'm a little curious if it'll work at higher power, so maybe I'll turn up the wire speed a little bit. So this extra 2.5 inches of bead was hotter. Definitely looks better. And I think on the current meter I saw it jump up into the 150 amp range a couple of times. Not sure what the average was or what the peak was. because that meter, it's not instant and it's not logging anything. But yeah, definitely hotter. I'm not quite sure how hot I want to push it. I'm not sure if I want to find the absolute limit, but so far that Viking seems pretty stout. Over here, the cables were getting a little warm, and I feel a little warmth right in this area. So probably best to let this thing rest for a little bit. See what this thing shows for. Showing 75%. No, they're both showing 75%. Around 8 inches of weld. Could probably get at least 3 times that out of this thing. Pretty impressive. So what's interesting is, I mean, this pretty much proves I think you could do some welding with just 2 of the Vikings. A lot better bang for the buck than the NOCOs. But I'm still not sure if I'm sold on the design. So far, yeah, I'm really liking this Ready Welder. Just need to do some more practice with it and get proficient. And of course, explore my various battery options. All right, so now I'm going to check this diode pack right here. So this diode pack is what protects the Viking battery pack from alternator charging voltage, or if you happen to connect it to some battery source that has a higher voltage than the internal battery. This prevents it from overcharging or charging too quickly, stuff like that. So I've got my multimeter in diode check mode. So if I measure this across this in one direction, I should see the diode forward voltage drop. So we got 0.098 volts. And if I reverse the leads, I should see overload. There should be no current flowing in the other direction if the diodes are still good. Yeah, pretty cool. So I'm pretty stoked. So far the price versus performance on that little Viking seems pretty decent. And it should be able to support even more current than I was just pushing through here. I think somebody else did a test on YouTube where they were actually cranking over an engine with it, and they were seeing momentary peaks like well over 250 amps. So you probably don't want to weld for too long at a stretch, but yeah, it might be able to punch a little bit more power through there. And yeah, if I can hone my skills and make prettier looking beads with this process, I'll be pretty impressed. I'm liking this thing. I guess I've never seen really high power Flux-Core. It seems like most of the Flux-Core videos you see are people with just the absolute cheapest machine that money can buy. It barely has enough power to run even a thinner wire. But yeah, this higher power Flux-Core seems to be working great. And this whole process for, improvised field expedient welding, trail repair type stuff, this seems to be a lot easier on batteries than stick welding. So we were seeing really high peak currents when you were just trying to strike an arc with the stick electrodes on 36 volts. And yeah, when we tried that with a 1/4 inch, huge stick electrode, I think that's what did damage to that NOCO over there. Took out the relay and the diode pack just from overcurrent just when you're starting the arc. But we were seeing pretty high currents even with 1/8 inch rods trying to stick weld off batteries. That initial arc strike is essentially a short circuit because you've got quite a big conductor there. So it draws really high currents, even though once you're welding, the current drops off a little bit because of the resistance of the arc. But this seems to have pretty low current, or not necessarily low current, but the initial current when you start welding with this Ready Welder, it seems to be about the same as while you're welding. And I think a lot of that has to do with just how thin this Flux-Core wire is right there. It provides good resistance to limit the current going through. So I'm pretty impressed with this, pretty happy. And yeah, thanks to my buddy Jimmy for letting me test with his other NOCO and with his car batteries and stuff. We definitely learned a lot together. Oh yeah, and just for reference, this is 3/8 plate. I'm running 035 Flux-Core wire. I think I mentioned that already. And my wire feed speed was right there. So I'm on 1, 2, 3, 4. I'm on the 4th dot there. But you can't necessarily use that on another Ready Welder because you can actually remove this knob and reposition it. So here, yeah, that's my 0 point. So my 0 point is just slightly past this first dot. So that's more for my own reference than anything else. So I can somewhat repeat this setup. I just did a quick 6-second pull on the wire here and measured it out, and it was 29 inches. So the wire feed speed I was running on that second bead was 290 inches per minute. And I don't know the exact voltage of the battery pack because I didn't measure that while I was welding, but probably somewhere in the 23 volt range. Yeah, 22, 23 volt range is probably my best guess there.